The issue involves an electrical problem identified in a residential setting, specifically an abnormal voltage reading between the hot wire and ground. After replacing a receptacle, a reading of 70 volts was observed between the hot conductor and ground, while the voltage between hot and neutral remained at a standard 120 volts. Further investigation revealed that the problem was linked to one of 3 cables entering the electrical box, labeled Box B. The presence of an open ground in this particular cable was found to be the root cause of the unusual voltage measurements and affected downstream receptacles. The explanation lies in understanding how an open ground can disrupt the normal flow of current and create a voltage potential where it shouldn't exist. In a properly functioning electrical system, the ground wire provides a low impedance path for fault current to return to the source, typically the electrical panel. This low impedance path facilitates the rapid tripping of a circuit breaker or ground fault circuit interrupter (GFC). In the event of a ground fault, quickly disconnecting the circuit and minimizing the risk of electrical shock or fire. However, when the ground wire is broken or disconnected, this low impedance path is lost. This is what we refer to as an open ground. Without a proper ground connection, fault current cannot easily return to the source. This can lead to a hazardous situation where metallic enclosures or other grounded parts of electrical equipment can become energized, posing a shock hazard. Furthermore, an open ground can cause erratic voltage readings as observed in this scenario. The 70 volts reading between hot and ground is a manifestation of the disrupted current flow and the voltage potential created by the open ground. The fact that the issue only arises when the third cable is connected indicates that the open ground is located within that specific cable or its connections. The upstream receptacles are not directly affected because they are still partially grounded through the other 2 cables. However, the downstream receptacles experience the full effect of the open ground, as they rely on the faulty cable for their ground connection. The solution to this problem involves systematically locating and repairing the open ground. Firstly, a thorough visual inspection of the cable and its connections should be conducted, paying close attention to any splices, terminations, or areas where the cable may have been damaged. Because the area has been remodeled, it's crucial to inspect any wiring changes or modifications that may have been made during the remodeling process. Secondly, a continuity test should be performed in the ground wire of the affected cable. This test involves using a multimeter to measure the resistance between the ground wire at the receptacle box and a known good ground, such as the grounding bus bar in the electrical panel. A high resistance reading indicates an open circuit, confirming the presence of an open ground. Thirdly, once the location of the open ground has been identified, it must be properly repaired. This may involve splicing in a new section of wire to replace the damaged portion, or completely replacing the cable if the damage is extensive. All splices and connections must be made in accordance with the National Electrical Code (NEC), using approved methods and materials. Fourthly, after the repair has been completed, it is essential to verify that the ground connection is now properly functioning. This can be done by performing another continuity test and ensuring that the resistance between the ground wire and a known good ground is low. Additionally, the voltage between hot and ground should be measured to confirm that it is now within an acceptable range, typically close to 120 volts. Fifthly, if the open ground is not readily apparent or if the continuity test does not pinpoint the exact location of the break, further investigation may be necessary. This may involve using a wire tracer, which is a device that sends a signal through the wire and allows you to trace its path, helping to identify any breaks or discontinuities. Wire tracers can be particularly useful when the cable is concealed within walls or ceilings. Sixthly, in some cases, the open ground may not be located within the cable itself, but rather at a connection point, such as a receptacle or a junction box. Therefore, it is important to carefully inspect all connections associated with the affected circuit, ensuring that they are tight, clean, and properly made. Seventhly, it is also worth considering the possibility of a shared neutral connection. In some older electrical systems, it was common practice to share a single neutral conductor between multiple circuits. If the neutral connection becomes loose or disconnected, it can create a similar effect to an open ground, causing voltage imbalances and erratic readings. To rule out this possibility, the neutral connections of the electrical panel and at all affected receptacles should be inspected. Eighthly, if the problem persists even after thoroughly inspecting and repairing the ground wire and neutral connections, it is possible that there is another issue at play, such as a faulty appliance or piece of equipment that is introducing a ground fault into the system. To isolate this possibility, all appliances and equipment connected to the affected circuit should be unplugged or disconnected, and the voltage readings should be rechecked. Ninthly, if the voltage readings return to normal with all appliances and equipment disconnected, then the problem is likely with one of those devices. Each device should be tested individually to identify the one that is causing the ground fault. Tenthly, safety is of paramount importance when working with electrical systems. Always to energize the circuit before performing any work and use appropriate personal protective equipment PPE, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is always best to call a qualified electrician. The principles of electrical grounding are essential for understanding how electrical systems function and how to troubleshoot problems. Grounding provides a safe path for fault current, protecting people and property from electrical hazards. An open ground disrupts this path, creating a potentially dangerous situation. By understanding the causes and effects of an open ground, and by following a systematic troubleshooting approach, electrical problems can be safely and effectively resolved. The voltage from hot to ground being 70 volts instead of the expected 120 volts indicates a problem with the grounding or neutral wiring. When the third cable is connected, it causes an open ground condition in box B and downstream. This suggests the third cable has a compromised or disconnected ground wire, disrupting the grounding path for downstream outlets. Here's a detailed approach to diagnose and fix the problem. Firstly, safety is paramount. Always turn off the power at the breaker before working on electrical wiring. Use a non-contact voltage tester to verify the power is off. Secondly, systematically inspect each wire in box B. Check the hot, neutral, and ground wires for any loose connections, corrosion, or damage. Use wire strippers to ensure the wire ends are clean and properly connected. Thirdly, with the power off, use a multimeter to check the continuity of the ground wire in each of the 3 cables. Set the multimeter to the continuity setting, which usually has a diode symbol or an ohm symbol. Test between the ground wire in each cable and a known good ground, such as the metal box itself or the ground bus bar in the electrical panel. If the multimeter shows no continuity, there is an open ground in that cable. Fourthly, focus on the third cable, since connecting it causes the open ground issue. Trace the third cable back to its origin, checking all junction boxes and connections along the way. Look for any signs of damage, loose connections, or improper wiring. Pay special attention to areas that have been remodeled, as these are often the source of wiring problems. Fifthly, if you find a loose or damaged ground wire, repair it by tightening the connection or replacing the damaged section of wire. Use wire connectors or wire nuts to make secure and code-compliant connections. Always use the correct size wire connectors for the gauge of wire being used. Sixthly, after repairing the ground wire, retest the continuity to ensure the ground path is now complete. If the multimeter shows continuity between the ground wire and a known good ground, the problem should be resolved. Seventhly, once the ground wire issue is fixed, reinstall the receptacle in box B and reconnect all 3 cables. Ensure all connections are tight and secure. Turn the power back on at the breaker. Eighthly, use a voltmeter to check the voltage at the receptacle in box B. You should now read approximately 120 volts between hot and neutral, 120 volts between hot and ground, and 0 volts between neutral and ground. If the voltage readings are correct, the problem is solved. Ninthly, test the receptacles downstream from box B to ensure they are also working correctly and have proper voltage readings. If any of the downstream receptacles still have issues, repeat the troubleshooting steps to identify and fix any additional wiring problems. Tenthly, it's also important to consider the age and condition of the wiring in the house. If the wiring is old or damaged, it may be more prone to problems. In some cases, it may be necessary to replace the wiring entirely to ensure safety and reliability. The NEC Article 250 provides detailed requirements for grounding and bonding electrical systems. This article covers topics such as grounding electrode systems, equipment grounding conductors, and bonding of metal parts. Additionally, N.E.C. Article 310.16 provides ampacity tables for conductors, which are used to determine the appropriate size wire for a given circuit. These tables take into account factors such as the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. When working with electrical wiring, it's important to follow all applicable codes and standards to ensure safety and compliance. Always consult with a qualified electrician if you have any questions or concerns. The unusual voltage readings observed in Box B, specifically 70 volts from hot to ground, strongly suggest a compromised or floating ground. In a correctly wired circuit, the voltage from hot to ground should be approximately the same as the voltage from hot to neutral, typically 120 volts in the standard residential setting. The fact that you're measuring only 70 volts from hot to ground indicates that the ground wire is not providing a solid, low impedance path back to the source. This can be caused by several factors, including a loose or disconnected ground wire, a corroded connection, or a break in the ground wire somewhere along the circuit. The observation that the issue only arises when the third cable is connected further narrows down the problem to that specific cable. This suggests that the ground wire within the third cable is either not properly connected or has a break in it. It's also possible that the third cable is connected to a different grounding system than the other two cables, which could create a voltage potential between the two systems. To systematically diagnose and resolve this issue, several steps should be taken. Firstly, a thorough visual inspection of all wiring connections in Box B should be conducted. This includes checking the tightness of all screws and wire connectors, looking for any signs of corrosion or damage, and ensuring that all wires are properly connected to their respective terminals. Special attention should be paid to the ground wire connections, as these are the most likely source of the problem. Secondly, a continuity test should be performed on the ground wire of the third cable. This test involves using a multimeter to measure the resistance between the ground wire at Box B and a known good ground, such as the grounding bus bar in the electrical panel. A high resistance reading indicates an open circuit, confirming the presence of an open ground. If the continuity test reveals an open ground, the next step is to trace the third cable back to its source, checking all junction boxes and connections along the way. Look for any signs of damage, loose connections, or improper wiring. If the cable passes through any remodeled areas, pay special attention to these areas, as they are often the source of wiring problems. Thirdly, if the open ground is located within the cable itself, it may be necessary to replace the entire cable. However, if the open ground is located at a connection point, such as a receptacle or a junction box, it may be possible to repair the connection by tightening the screws or replacing the wire connector. All repairs should be made in accordance with the N.E.C. using approved methods and materials. Fourthly, after the repairs have been completed, a continuity test should be repeated to ensure that the ground path is now complete. Additionally, the voltage between hot and ground should be measured at Box B to confirm that it is now within an acceptable range, typically close to 120 volts. Fifthly, it is also important to consider the possibility of a shared neutral connection. In some old electrical systems, it was common practice to share a single neutral conductor between multiple circuits. If the neutral connection becomes loose or disconnected, it can create a similar effect to an open ground, causing voltage imbalances and erratic readings. To rule out this possibility, the neutral connections at the electrical panel and at all affected receptacles should be inspected. Sixthly, if the problem persists even after thoroughly inspecting and repairing the ground wire and neutral connections, it is possible that there is another issue at play, such as a faulty appliance or piece of equipment that is introducing a ground fault into the system. To isolate this possibility, all appliances and equipment connected to the affected circuit should be unplugged or disconnected, and the voltage reading should be rechecked. Seventhly, it is crucial to ensure that the electrical panel itself is properly grounded. The grounding electrode system, which typically consists of a ground rod or a metallic water pipe, provides a low impedance path for fault current to return to the source. If the grounding electrode system is compromised, it can affect the performance of the entire electrical system, leading to voltage imbalances and other problems. The grounding electrode system should be inspected periodically to ensure that it is in good condition and that all connections are tight and secure. Eighthly, the size of the ground wire is also an important consideration. The NEC specifies the minimum size ground wire that is required for each circuit based on the size of the circuit breaker or fuse. If the ground wire is too small, it may not be able to carry enough fault current to trip the breaker or fuse, which can create a hazardous situation. The ground wire should be sized in accordance with the NEC and should be properly connected to the grounding bus bar in the electrical panel. Ninthly, the type of wiring used in the electrical system can also affect its performance. Older types of wiring, such as knob and tube wiring, may not have a dedicated ground wire, which can make it difficult to provide a proper ground path. If the electrical system contains older wiring, it may be necessary to upgrade the wiring to a more modern type, such as non-metallic sheath cable, which includes a dedicated ground wire. Tenthly, safety is of paramount importance when working with electrical systems. Always de-energize the circuit before performing any work and use appropriate PPE, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is always best to call a qualified electrician. The key to solving this problem is a systematic approach that involves careful inspection, thorough testing, and proper repair techniques. By following these steps, you can safely and effectively resolve the issue and ensure that the electrical system is functioning properly.